Here, I'm using the NeuroSky Mindset BCI to cognitively control the LEGO Mindstorms test article. The vertical bar in the top right of the display corresponds to the neural signal strength that is being picked up from my brain. I purposely stop concentrating to make the robot stop and then concentrate to again make it move forward. The next clip demonstrates EMG facial expression control capability of again the LEGO Mindstorms test article. You can see me clenching my jaw to indicate to the Nia control panel software my desire to move the robot forward. While limited to but one EMG facial expression command, the OCZ Nia proved to be very reliable. Here, the Emotive BCI is being used to generate forward, reverse, spin right, and spin left motions on the LEGO Mindstorms robot. The test evaluator uses EMG facial expression jaw clench for forward motion, smile for reverse motion, furrow brow for spin left, and raise brow for spin right. After prolonged use, the damp, non-invasive sensor pad contacts which conducted the EMG signals to the headset became corroded, thus making it more difficult to precisely control the motion of the robot. Because the Emotive BCI can simultaneously listen for up to 4 EEG cognitive or EMG facial expressions, it was potentially suited for dynamic control of an aircraft in flight. Here, I'm flying a glass cockpit Cessna 172 using the same EMG facial commands as in the previous clip. You can see my facial expressions as I perform a left bank and then straighten the plane out again. To maintain control of the aircraft, it was necessary to supply many facial expressions in quick succession to keep the airplane flying in a predictable manner. Even so, shortly after the end of the clip shown here, the plane went into a steep left turn followed by a steep right turn from which it was not possible to recover. Thus, the flight ended with destructive impact. Finally, the Orion CEV is being flown with cognitive commands as the spacecraft performs docking maneuvers with the ISS. Forward, reverse, right and left translational maneuvers correspond to push, pull, right and left cognitive commands for guidance towards the lid's docking system using the simulation's bore sight, bird's eye, and side views. Cues are built into the display that allow the signal strength and direction of the generated commands to be monitored without looking at the emotive control panel, thus leading to the first successful docking of the Orion spacecraft using EEG cognitive commands.
Wow. Cool.
That's amazing.
I can't believe I did that.